very good day to our respected lecturer, Dr. Marwan. Today, we would like to present to you about the cellular network design. So, I am Praveen, and my group members are Kishan Rao, Shiva Shukiran, and Revan Singh. So, the area that we chose is Georgetown, and the surface area of Georgetown is 305.77 square kilometer. The population will be 794,313 people. So for us, we actually assume few parameters, which will be the total available spectrum, operating frequency, full duplex channel, and minimum CI. For the total available spectrum, it is actually 22.4 megahertz, while the operating frequency will be 1800 megahertz. For the full duplex channel, the frequency will be 60 kilohertz, while the minimum CI will be 15 dB. So now let's look at the calculation part. So in order to calculate the total number of channels, the formula will be total number of channels equal to total available spectrum over channel bandwidth. As we know, the total available spectrum will be 22.4 megahertz, while the channel bandwidth will be 60 kilohertz. So when we divide this, we get a number of channel which is 373 channel. So the channel per cell will be total number of channel over n. So the n is the cluster size. So we actually assume the cluster size is 7. So 373 divided by 7 will be 53 channels per cell.
Okay, now I'll be talking about the grade of service, which is 2%. The grade of service is actually to measure the ability of a user to access to trunking system. In this GOS, we are using a Alang B system to find out our total traffic intensity. So for the traffic intensity per user, we have set it to zero point 0.1. How do we get this is we assume that average 2 calls per hour and a call duration of 3 minutes. So from the table, along B traffic table, we could get the total traffic intensity, which is A, is 43.06. So for the number of users per cell is actually total traffic intensity over traffic intensity per user. So we divide these two values and we could obtain the number of users per cell, which is 430 users. Next. So as we all know, we are using the frequency FDMA, which supports 53 users for 53 channels. And thus the population cannot support uh, the amount of population couldn't be supported by the FDMA system. So we improvise and change to different multiple access, which is TDMA. Why do we use TDMA is it can assign more users by sharing the same bandwidth by just differenting with different time slots. So we assume that 7 users per channel and we divide it, we multiply it with the total number of users and we could obtain 3010 users. Next. So for the minimum number of cells, the total population over number of users per cell. So from the data, the total population is 794,313 divided by the number of users per cell. We could obtain 263.89 and we round it off to 263.
So now, to calculate the surface area per cell, we use the formula total area over the number of cells, which is equals to 305.77 kilometers divided by 263 number of cells, which will give us a total surface area for one cell is equals to 1.163 kilometers square. To get the radius of each cell, we use We use the circle theorem to get the surface area over 2.6, which is equals to 1.163 over 2.6 square root to get a radius of 0.669 kilometers. Now, using free space propagation model, the path loss can be taken as 2. The received power is PR equals to PT plus GT plus GR minus bracket 32.44 plus 20 log D plus 20 log F, where D is the radius of the cell, which is 0.669, and F is the operating frequency, which is 1800 MHz. And using this formula, we can get the received power equals to negative 47.05 dBm. Next, from an article in Malaysia Wireless, the cost to build one cell is 8,000 ringgit. Thus, we can calculate the total cost of this whole project, which is equals to 8,000 ringgit for one cell times 292 number of cells, which gives us a total cost of RM 2.336 million ringgit. And we can calculate the cost for one user by dividing 2.336 million with the total number of users, which is 794,313, which gives us a value of cost per user equals to 2.2 ringgit and 94 cents. Thank you. Now I'll pass on to my next teammate.
So next is to estimate the additional investment needed in 5 years when there's an increase of 20% in population in subscribers. Sorry. So if there's an increase of 20%, then the total population will be 953,176 people. So this will also required to upgrade the 2G line to 3G current technology because it will not support the system, the total population. And referring to the article in the comms update website, the upgrading cost will come around an estimate of 400 million ringgit. So to calculate the minimum number of cells is to divide the total population over the number of users per cell. So the total population now is 953,176 divided by 3,010. So the number of cells is 317 cells. Next. So since the initial number of cells is 292, thus there's an additional of 25 cells that needed to be added. So we can calculate the number of additional cost, which is 8,000 multiplied with 25, and we will get 200,000 ringgit. So the additional cost per users is divided by the additional total cost, which is 200,000 over 158,863, and the total cost per user is RM 1 ringgit and 26 cents. Next. Thank you.